Alright guys, welcome to 5.2 Polynomials, Linear Factors, and Zero. In 5.2, we are going to analyze a polynomial. I'm going to show you how to find the zeros of a polynomial. In other words, find all the points where the graph will cross the x-axis. That's the zero. We are also going to graph polynomial functions using its end behavior and the zero. So make sure you remember how to look at a function and know its end behavior. Recall that in chapter 4 we solved quadratic equation of these forms by factoring. It turns out that we can also solve polynomial equations with any degree greater than 2 pretty much in the same way. So first, we need to know how to factor, or we need to review how to factor a polynomial. When factoring a polynomial, the first thing you want to look for is you want to look for the GCF. Looking at these three terms, the GCF for these three terms would be x. The first thing you do is you factor out an x. Factoring out an x, we got x squared plus x minus 4 left. Alright, turns out that inside this parentheses is a trinomial with a degree of 2. So now we can factor this by using the Xbox method that we worked on in chapter 4. So take the letter x, put them in here. Ask yourself what two numbers multiply would give you, that should be 12. What two numbers multiply would give you negative 12, but added together gives you 1. Turns out that 4 and negative 3 will do the trick. So bring this x down, and guess what? You have factored a polynomial. Alright? Okay, great. Let's move on. I want you to be able to find the zeros for this polynomial. Now this polynomial has been factored for you. So find the zeros. And find the zeros means find the root, which means find the point where it crosses the x-axis. Alright? So to find the zero, given a polynomial that's already factored, first thing you do is you set y equals to 0. And notice that there are three factors we're looking at. Next step is to take each of those factors and set them equal to 0. So first, second, and third, set each one of them equal to 0. So I set the first one equal to 0, so that's x equals 0. Set the second one equals to 0, solve for x, x equals to 3. Set the third factor equals to 0, solve for x, x equals to negative 5. And so remember, these are the x values where the graph crossed the x-axis. So we have found the zeros. Alright, very good. Now, second thing I want you to be able to do after you know how to find the zero is I want you to be able to graph the function. To graph the function, the first thing you do is you find all the points, or not all the points, just find the points for the x values between the zeros. Now this can sound really confusing, but here's what I mean. What you do is you draw your x-axis. Start off by plotting your zeros, which are at 0, 3, 1, 2, and 3. And then negative 5, negative 1, negative 2, negative 3, negative 4, and negative 5. Alright, these are your zeros. The graph will basically cross the x-axis there, crosses there, and then crosses there. Those are the zeros. I would like you to pick one x value between negative 5 and 0, and one x value between 0 and 3. So let's choose negative 3, and let's choose 1. For each point chosen, go ahead and find the points. For each x value chosen, go ahead and find the point. To find the point, we take each of the chosen value and we plug it into the original function to calculate the y value, And that's how we write the point. So replacing -3 into each one of these x's, let's see what we get. Let's do it in our head. So -3, replace it in here. That means that I'm going to get -3 times, plug -3 in there. That's going to make it -6. Plug -3 in there. That's going to make it 2. So I'm going to have -3 times -6 times 2. That's going to give me 36. So y equals to 36. Therefore, I have 1 point so far, which is -3 and 36. Do the same thing for x equals to 1. Plug that in there. I'm going to have 1 times -2 times 6. So 1 times -2 is going to be -2 times 6 is going to be -12. So y equals to -12. My other point is 1 comma -12. Awesome. Alright, the last thing, or one of the last things you have to analyze is your end behavior. Now the end behavior is determined by knowing the degree of the polynomial and the leading coefficient. So one way to identify the degree of the polynomial is to multiply everything out. Now if you look carefully, there are three x's being multiplied together, and if you multiply 3 x's together, for sure you're going to get an x cubed. Now there's no coefficient in front of each one of these x, so when you multiply them together, you're going to get 1x cubed as your leading term. Alright, and if you can't see what I just said, go ahead and multiply these out and you'll know what I mean. But anyways, the leading term is going to be 1x cubed. Therefore, the degree is going to be 3, and the leading coefficient, which is 1, we call that number A. That number is positive because 1 is positive. Now, using the table on how I summarize the end behavior, by knowing that your degree is 3, which is an odd, and A is positive, you can interpret the end behavior of this graph to be down and up. In other words, at the left behavior it's going to be going down, and at the right behavior it's going to be going up. Awesome. And if you need to, you can always review this end behavior table. Last step is we use the zeros. So remember, these are the zeros that we found in part A. X equals to 0, and y is going to be 0 because that's why it's called the zeros. Okay, 3, 0, and -5, 0 because these are the point where the graph will cross the x-axis. So we use the zeros, and the additional points which I found over here in step number 1, label that as -3, 36, and 1, -12, and the end behavior to sketch the graph. So I'm going to start off by sketching the end behavior. So the graph, actually let's plot these points first. So the zeros will be 0, 0, 3, 0, and -5, 0. The additional points are -3, 36. So -3, 36. Let me change these values to be, let's make each one 5, 10, 15, 20, 25, 30, and then 36. Okay, so somewhere over here is 36. Plot 36. 1, -12. So 1, -12. So -5, -10, and -15. So 12 should be over here. Alright. Now, my end behavior. My end behavior is down and up. So down, the left end behavior is down. So draw an arrow that's heading down. Alright. The right end behavior is heading up. So toward the right of this last point, draw an arrow that's going up. And then you're going to connect these points. So you're going to go, okay, the graph has to look like this. See? It has to cross through -5. It has to go all the way up high to touch 36. And it goes back down to touch 0, 0. And it comes over here and it touches 1, -12. And it goes back up and it connects with the other arrow because that's the upper end behavior. That's how you sketch the graph of a function without a graphing calculator. And I know that might be confusing, so if you need to, you can always rewatch this video. Let's move on. This should be example number 3. All right. So, example number 3, I wanted to show you how to write a polynomial function if these are the point that it crossed the x-axis. So, say if this is your x-axis, here's where 0 is, and you got, 1, 2, 3, 4, 5, 6, and 7. 5, 6, and 7. Your graph crossed the x-axis, so it might look like this. Here might be your y-axis. This might be your y-axis. Your graph might look like this. I don't know what it does, but here's what it does. The graph crossed the x-axis like that. And I want to know what could be a possible polynomial. So, if these are the zeros, then that means that it has to come out of a binomial that looks like this, which is x minus 5, x minus 6, x minus 7. All right? And so, in order for us to get the polynomial, all we have to do is multiply all these together. So, multiplying these together, let's start with these guys. We're going to get x squared minus 11x plus 30. And then now multiply it with the binomial x minus 7. So if we multiply that with the binomial x minus 7, we're going to get x cubed. This is going to be negative 11x squared plus 30x. Repeat the same process for the number negative 7. Negative 7 times x squared is negative 7x squared. Negative 7 times 11x is going to be plus 77x, followed by 210. Combine all these together. You got x cubed minus 18x squared plus 107x minus 210. This is the polynomial that has 5, 6, and 7 as its roots. So basically, we're just going backward from what we've done before. Very good. In example 4, I want to show you what the word multiplicity means. So, in order for you to understand the word multiplicity means, let's first find the zeros for this function. Find the zeros of each function. So, to find the zero, start off by setting the function equal to 0, because 0 means where the point where the function crossed the x-axis. So x cubed minus 8x squared plus 16x. Start off by factoring this polynomial. I can pull out an x. I'm left with x squared minus 8x plus 16, right? Continue to factor the inside. And the inside, if factored, you're going to get x minus 4, x minus 4. Solving this polynomial, you're going to see that the roots are, or the zeros are 0 and 4. All right. Now, because there are two binomials that are identical, x minus 4 and x minus 4, we say that 4, the solution 4, or the zeros of 4, or the root of 4, has a multiplicity of 2, because there are two identical binomials. And that's what multiplicity means. All right? So 0 and 4 are the roots, but 4 has a multiplicity of 2. 0 has a multiplicity of 1. Okay? But we only have to state the multiplicity of multiple zeros. So here is the multiple zeros. So we say 4 has multiplicity of 2 because there are two identical binomials. Sorry about that. Let's do one more. Find the zeros and state the multiplicity of the multiple zeros. I'm going to go ahead and factor out an x squared. So set that equal to 0. Factor out an x squared. I have x squared minus 2x plus... Actually, I can't factor out an x squared. I can only factor out an x. So I have to factor out an x. But I gotta arrange it first too because the function is not in descending order. So start out by rearranging the function. X to the 4th minus 2x to the 3rd minus 8x squared plus 16x. I'm gonna go ahead and factor out an x cubed minus 2x squared minus 8x plus 16. Alright, I am now going to factor these for the polynomial, the inside polynomial by grouping. So group the first two terms. I can pull out an x squared if I group the first two terms. What I'm left with is x minus 1, 2. Okay. I can also group the last two terms. Whenever you have a polynomial 4 terms, you can always try grouping. Factor out a negative 8. You have x minus 2. Altogether, we got x minus 2 is the common factor, and then x squared minus 8. Alright? And then you have an x down here. So, the zeros are going to be x equals to 0, x equals to 2, and then x equal to, you have to solve for this factor by taking the square root, by setting it equal to 0 and then taking the square root. But if you did that, you're going to get negative 2 rad 2 and then 2 rad 2. Alright, so there are no binomials that repeats, and therefore there isn't any multiplicity other than 1. Alright, very good. The last thing is knowing how to determine the relative maximum and relative minimum of a graph or of a function. Relative max and relative min are basically the turning points of the graph. So if you look carefully at this function, this is a cubic function. The graph actually turns here. The graph turns here. And at that turning point, it's kind of like where the parabola opens up, so this is a relative min. Alright? Or in other words, around its neighborhood, that point is the smallest point. We call it a relative min. On the contrary, when you get to the other point, this point is referred to as a relative max because that is the largest point within its neighbor. Or you can think of this as a parabola that opens down, so therefore that has to be the max. Alright? So find the relative max and min of, and let me give you a function to try, f of x equals to x cubed plus 3x squared minus 24x. And we cannot do this without the assistance of a graphing calculator. So we'll need to use a graphing calculator when we're asked to find the relative max and relative min. So let's go ahead and type this into a calculator. Okay, go ahead and take out your calculator. And I'm going to type it in. So x raised to the 3rd plus 3x squared minus 24x. All right. Graph the function. Okay. Now the function is a bit out of bounds. It's really big. The function is actually really high. So we're going to go ahead and zoom out. Let's go ahead and zoom out. Zoom out. and give it some time. It's doing the calculation. Okay, it's still pretty high, but we're able to catch one of the points. All right, so let's go ahead and go back to our window, and let's modify the y maximum. Let's make it 50 and see what we see. See if we're able to see the graph. Making it 50, I now am able to see the graph. No, not yet. I'll make it 60. Go back to your window. Try y maximum to be 60 and see if that helps. Okay. Give it some time. It's doing the calculation. And I think we're getting closer, but the graph hasn't been exposed yet. So let's go back to the window and make it 70. 75. And let's see if that's within our bound. We're getting pretty close. All right, let's make it 80. 80 should be good enough. 80 graph. Do it until the graph is fully exposed. And it is fully exposed. So now we're going to go ahead and find the relative max and relative min. That's a relative max, that's a relative min. So, second, calculate. And I'm calculating the maximum. Alright? So what you have to do is the calculator is going to ask you to choose a left bound. So you want to toggle the little cursor until it's to the left of the maximum, hit enter, and toggle it again until it's to the right, hit enter, and then hit enter again, and that will tell you, the calculator will tell you what the maximum is. So the maximum, the relative maximum of this function is it's 80. Okay. And then let's go ahead and find the min. So second, calculate, and we can calculate the minimum, which is 3. All right. The left bound, right bound, hit enter again. And it tells us that the relative min is negative 28. All right, so go ahead and write relative max 80, relative min negative 28. Awesome. I will see you guys next time.